The whole point of Stella is that it lets you model complicated systems. And particularly what it lets you model is the transfer of different amounts of stuff or energy between different areas. So for example, in middle school, you may have learned about the water cycle. You know, that water evaporates, turns into clouds, falls down as rain or snow or ice or whatever, then it runs off. You could model that in Stella because it's a flow or a transfer of stuff between different places. So in Stella, this is always the sort of what the program will look like. And almost always you want to click on this tab over here that says Model. There's a bunch of different tabs here. Really the only relevant one for us is going to be this Model tab. Okay, and you can see that there's these different icons up here. And we're really only going to use 3 or 4 of these icons. So you can see the first one, when I hover over it, is called a stock. Okay, and a stock is just the same thing as a reservoir or the same thing as a space where a certain amount of stuff can exist. So for example, in our water cycle analogy, a stock could be the ocean, a stock could be the lake, a stock could be the clouds, a stock could be a river, whatever. So we're going to drag right there, and we're going to call this, well, let's just, what the hell, let's just measure the water, or model the water cycle. So we're going to call this thing the ocean. And we're going to make a couple stocks. So we'll also make clouds, and we'll make lakes, and we can make, I don't know, like a river. Actually, let's not so much make a river. Let's just do these 3 to start with. Okay, and we need to connect them, right? So to connect them, we're going to use the next icon, which is called a flow. Okay, and a flow just shows how different things are connected. So we're going to take this ocean thing, and we're going to connect it over to the cloud. So can you see what I did? Here, let me do it again. Oops. Click the no name thing, delete it. So first I click and drag on the ocean. Then I'm going to click and drag on this thing to make it go over to the clouds. Okay, and we're going to then name it. We're going to call this thing evaporation. Okay, and right now these things all have question marks because we haven't defined how much is in them, or how much is in the ocean or the clouds or the lakes initially, and then we haven't defined how fast evaporation works. So some of the clouds then go back, click and drag, some of the clouds go back into the ocean in the process of what we call rain, and some of those clouds also go into the lake. Rain, right? Oops. So you can call this terrestrial rain or something. And notice once I have these things, I can drag them around and they just sort of figure out where to go. And then last thing that we're going to connect is we're going to connect the lakes over here to the ocean. And we're going to call this, I don't know, runoff or something. Okay, so let's start by putting in the amounts for these different things. So when I click here, notice it says enter initial value here. We're going to put in relative units. So we'll just call this 100. I'm just completely making this stuff up right now. So we'll just say that this is 100. After we've entered in that amount, just one thing that's important to know is if we put in those curly Q brackets, we can put in comments. So we can say arbitrary initial number not actually measuring volume, mass, whatever, water. Again, notice I have to put it in those curly Q brackets things there. So now we can go on and put the initial amount in the clouds. We'll say that that's, I don't know, 2, so 2% of the ocean value. And we can say lakes are also about 2. Okay. Now we can go over here to the evaporation. We'll make this slightly more interesting. Well, let's actually make it not interesting. We'll just say evaporation is a constant rate of 1. Okay, and again, we're not worrying about the units on this thing. Okay, so notice, by the way, after I click on that, that little question mark disappeared. And we're going to make the rain more interesting. What we're going to make the rain is we're going to make it relevant to the amount of clouds. So in other words, we're going to make the rain a function of the amount of water in the clouds. So to do that, what we need to do is we need to use this little connector tool. We click on the clouds and link it over to the rain. Do you see how I did that? I started dragging off the clouds reservoir, the cloud stock, and when I dragged onto the rain suddenly became highlighted. Now I double click on the rain and notice that there's an input I can say. So I can say rain equals clouds times, and we'll make it a sort of a percentage of the amount of water in the clouds. Makes sense? We can do the same thing over here with the terrestrial rain. Drag a connector from the clouds to the terrestrial rain, and we'll make it the same percentage. Whoops, clouds times 5%. And it might also make sense to make the same thing happen with the lakes, where lakes are going to be, the runoff from the lakes is going to be equal to the lakes times 10%. So the fuller the lake, the more runoff. So we've now created this really simple model, and something that you may be interesting to see is to see how it changes with time. So to do that, I click the graph, click down beneath on the graph, and I can see, this image here. I need to figure out what to actually include on the graph. So to do that, I double click on the graph, and we're going to look at a bunch of different things. So I click the clouds, and we're going to graph that. We can graph the lakes, we can graph the ocean, and let's look at the runoff as well. Okay. So now all four things are here. Notice that they're color coded. So clouds in blue, lakes in red, etc. And notice that the y-axis has different units for each of those four things. So what does it look like? It looks like 1 and 2 are both merged. See those brackets? And then 3 and 4 have separate units. And see how it's a black bracket? That means that is the units for both the clouds and the lake. Now I just go run, and it shows over some arbitrary time units how these things have changed. So the ocean has gradually gotten depleted. The lakes, where are the lakes? So that's right, the runoff and the lakes are the same amount, so they're slowly going up, and the clouds are slowly going up. So it might be interesting to look at this over a longer period of time. So again, what I did is I went to run specs, and instead of just going from 0 to 12, well, let's look at it from 0 to 100 and see if it keeps changing. We'll run it again. So we'll take more time. And we can see down here that it's showing how much of that run it's gone through. So interesting, it looks like the ocean initially dropped and then went up. The clouds leveled off. Same with the lakes and the runoff. So there's some issues with this model because we just sort of made it up. It looks like, yeah, I don't know why it's doing this, but whatever. We could go later figure out what's going on with it. One other thing is that this is, I think, the last thing I'm going to tell you about is you can also have inputs, or in other words, you can have these flows coming from outside. So this one we're going to call water from outer space. It turns out there's a significant amount of water that comes into our Earth from outer space each year. And everything else here is a cycle because it's all flowing together. The water from outer space is sort of coming in at a constant rate. It's a pretty low rate, but it's coming in constantly. And it's showing that cloud, that it's coming from outside the system. So we can go back to our graph, double click that, and see how things change, if they change at all, when we have that extra water coming in from outer space. And it looks like it's not changing much, probably because it was a really small amount of water that was coming in. So although this model is totally screwed up, it gives you a sense of what, of how this thing works. So to help you all in actually using Stella, here's what I want you to do. I want you to make a simple Stella model that is sort of related to the water cycle thing we just did, but just models how a bathtub works. And so you think about, you're going to have water flowing in, water flowing out, and think about the rate of the water flowing in, whether that's constant or if it relates to the amount of water in the bathtub, and then think about how the drain drains out. Is that a constant rate? Is it related to the amount of water in the bathtub? And something after you've done that simple model, take that model. I guess I should add, save it, and save their model. Then make a graph showing how the water in the bathtub changes with time. After you've done that, take that simple model and connect it to another bathtub, which is sort of in turn connected to the first one. So in other words, make a system of two bathtubs that are draining into one another, and where the amounts of water is going to be related to the amount of water in the other one. So you're making two interrelated systems draining back and forth, and obviously you really would need a pump somewhere. Doesn't matter. So this is entirely just to get you used to how Stella works and how to link these different things. After you've done this, try to graph it as well. And bonus points if you can make the two bathtubs cyclically sort of, drain and fill. In other words, try to make them a sinusoidal function. Hopefully that makes sense. Good luck doing that. We'll see what you all come up with at the start of class Tuesday.